Hey guys, I hope that I'm live right now. If you guys are able to listen to me properly, as well as there's no issues with the audio or the video, please do let me know. Hello everyone, I hope that I'm live right now. If you guys are able to listen to me properly, as well as there is no issues with the audio or the video, please do let me know. Good evening, everyone. Good evening. Am I audible to you guys? Please let me know, guys. Great. No issues, all good. Amazing, guys. Amazing. So, in today's class, I will be showing you guys the project that we are going to learn. Okay, I'll be giving you a brief introduction as well about the same. So we will look at it. I will let you guys know about the rest of the stuff so that you guys are absolutely clear with what is going to happen. Okay. uh, there are no issues with the audio, am I right? Okay, great. So basically what we'll be doing today is we'll just be going over the project itself. I will show you guys how the project will look like and what you're going to learn in the project. I will be making up I will be, so today we have some work right over here. So I won't be able to do the project today. So we'll be having another day, that is day 8 tomorrow, in which we'll be having the project. Will that be fine with you guys? Will that be fine with you guys? Please let me know. Guys, will that be fine with you? Please let me know. Because I want to make sure. So I went through the entire project and I tried to analyze the project. As you will be also able to see that it won't be possible for you to understand the project correctly in this 1 hour. So my thought process was to let me do one thing. I will release a video here tomorrow in which we'll go over all the concepts and all the important stuff that is required for the project. Uh, Tomorrow. So tomorrow we'll be having one more day. That is the day 8. Today I have some work as well. That is the reason why. But nevertheless, I will be showing you the project that you would be doing, and we'll be continuing according to that. Will that be fine with you guys? Please let me know. So let's do one thing. Let's first start off with seeing the project itself. Okay. So let's look at the project that we are going to learn and what we are going to build tomorrow. We will be using the convolutional neural network itself. I understand that convolutional neural network is a particular topic that you haven't understood properly. So I'll try to tell you guys some of the basic stuff today, and tomorrow as well in the video when we'll be doing the project, I will be letting you guys know about a little bit more in depth as well. Okay, so you don't have to worry about it. So as you're able to see, everything has been made in such a way that the notes and everything is also there along with the code and everything inside the notebook that we are going to make the project of. Okay, so as you're able to see, we have made everything in such a way that you guys will be able to enjoy the learning process. Okay, and also this is the project that we are going to make. Although we won't be like making the web app for the same, but I will also show you, we have already deployed this entire machine learning model. Okay, so this is the machine learning model that we have created using convolutional neural networks. If you're writing anything, so for example I'm writing 7 right over here, it will be able to recognize it and let you know that this is 7. If I'm writing 1 right over here, it will be able to recognize that this is 1 and it will like let you know. If I'm writing, let's say 9 right over here, so this 9 is not very good, so it is classifying it as 8. Okay, so let us try to build a bigger 9. It's, so it is classifying it as 1. So it has some problem with classifying 9, but as you're able to see, like for example 0. Okay, so it is classifying it as 0. If I try to classify 6, We have built it in a web app as well, as you are able to see, so that you are able to play around with these. Okay, the notes and everything, when we'll be doing the project tomorrow, I will be providing it and the description of the video itself. Okay, so you can keep the notes, you can upload it on your own GitHub, so it would be easy for you. Okay, but you will have to submit the project as well. Okay, so some of the parts in the notes I will be removing it, some of the parts of the project that you'll have to implement it yourself. In the video itself, I will be doing it. I will be coding the entire project so that you are able to understand. But the notebook that I will be providing you, some of the parts of that notebook would be missing, where you will have to write the own code. So I will be letting you know in tomorrow's video. You don't have to worry about it. Okay, it will be very easy. Okay, you don't have to worry about it. Okay, so let's focus upon your some of the concepts that are important for the project itself. Okay, so are you guys ready? Should we start learning? Please let me know. Or do you guys have any other questions as well? In that case, also do let me know. Should we start? Please let me know, guys. Okay, so only one of the person has said yes. Okay, so let's get started. No issues in that. So yesterday we were learning about convolutional neural networks, and so there are two aspects to convolutional neural networks. Okay, one is your convolutional layers. Okay, and the other one is your max pool layers. Yesterday we saw that we could arrange all the neurons in the same layer. Okay, we could arrange all the neurons in the same. Are we going to do all the coding and training thing in collab? Yes, Animesh, we are doing that because anyone who does not has a laptop will be able to complete the project as well. Okay, he can do it from his own mobile phone. That is the reason why we will be using Google Colab for the same. And of course, I don't expect everyone to have a very good laptop. So that is the reason why we will be using Google Colab. Okay. So yesterday we saw these type of layers in which in a single layer we were having neurons present, and each of these neurons were connected to each of the neurons or input layers in the first particular layer itself, and then to the next layer as well. Each of the neurons were connected to every single neuron in the first and the last layer as well. So these type of layers of neurons are called as densely connected layers. With Pandey, let's not focus upon the like project right now. Project we'll be doing it tomorrow. Let's focus upon the concepts right now that I'm teaching you, because if you're not able to understand these concepts, let alone deployment, you won't be able to understand the project itself. You will be like, shit, what is this? I'm not able to understand anything. So please try to focus upon what I'm teaching right now, because all these concepts will come while you will be making the project, and there I will not be able to like make you guys understand the entire thing. Okay, it's not as fully connected or densely connected layers. Okay, or dense layers as well. So all these are names of these type of layers. Now there are two more layers that we are going to learn. Okay, we are going to use densely connected layers as well. We are going to use convolutional layers as well as max pool layers. So let's try to understand about, so we have understood about densely connected layers. Now we need to understand about convolutional layers and max pool layers. So now let's first draw the image. Let me just put my phone on silent, otherwise it will keep on ringing. Okay, so let's try to understand convolutional layers itself. So let's try to, so convolutional layers have majorly two particular portions. Okay, three portions. Let's try to understand that. The first one is filters. We'll understand what filters are. The second one is the size of the filters. And the third one is the activation that you need to perform. So we have already understood what activation is. Let's try to understand what filters and the size of a filter basically means. So this is your image right over here. Okay, this is your image right over here. Now, when you're specifying the size of a filter as 3, okay, that means that you want to create a filter that is of the size 3 by 3. Okay, you want to create a matrix that is of the size 3 by 3. So that is the size of the filter. Now you're specifying that I want 16 filters. Now usually these filters are multiple of 2. So 16, 32, 64. These will be the like filters that would be present. Okay, so you are having the number of filters and the size of the filters. Now when you are specifying 16 filters, now each of these filters are generated by your module. So right now we are going to use TensorFlow 2.0. Okay, that is the latest version of TensorFlow that is currently there in the market. And TensorFlow is a library, a framework for doing deep learning stuff by Google. Okay, it's the largest framework in production. So what when you're specifying that, okay, I need 16 filters, so basically TensorFlow would generate 16 filters for you automatically. Each of these filters have its very own, each of these filters has its very own usage. For example, one of the filters might just be used to find horizontal lines. One of the filters might just be used to find vertical lines. One of these filters might just be used to find diagonal lines at 45-degree. One of these filters might just be used to find black spots. One of these filters might just be used to find squares, and so on and so forth. So these 16 filters, okay, are nothing else but matrices that look something like that. So it will be like 0, 0, 0, 1, 1, 1, 0, 0, 0. Now what this is doing is every time it encounters, so it will take an and. Okay, now this matrix will go over the photo. Okay, this is your photo, so it will go over the photo like this. So this is the first matrix that you're putting right over here. It will take and with that particular box. Okay, so anywhere where there is a straight line, so whenever there is a straight line that occurs, whenever there is a black straight line, it will take that into consideration and move further. For example, let's try to understand this by an example as well. Okay, so con 2D straight line filter. Let's try to look at an example if we are able to find something. Okay, it's difficult to find an example right over here for you guys. Usually when we used to work upon it, we used to make it on our own itself. Let's look at edge detection. And then let's go to edge detection itself. Okay, so let's look at this. Okay, so for example, this was an image, a black and white image of a cat. Okay, this was the actual image that was there, a black and white image of a cat. If I am making a straight line detection filter go over this particular image, I'm using a straight line filter to go over this particular image, it will end up with this image that I'm able to see. As you're able to see right over here, only the vertical lines or the horizontal lines are being detected. All the vertical and all horizontal lines, both the lines are being detected right over here, and nothing else. So this is basically what these filters are. These 16 filters are totally independent. You don't know which 16 filters that you are able to get. Okay, but these filters will then like convert your image from your actual image to an image where only that particular, so for example, edges or dots or circles or squares are being highlighted. Okay, only those features are being highlighted. Okay, are you guys able to understand why convolutional filters are used? Are you guys able to understand? If I'm using conv 2D, what would happen? So these 16 filters will make 16 different versions of this particular image, each of them having its having like the separate filter gone over through the entire image. So it's like 16 different snap videos that you are able to generate, or snap filters that you are able to generate at once. Are you guys able to understand this? Please let me know. Are you guys able to understand this? Please let me know, guys. Guys, are you able to understand this? Please let me know. So this is the first step to generate and find different features of the image. Okay, how will you be able to find the features? If you are able to find, like, okay, so vertical lines, horizontal lines, diagonal lines, squares, circles, these are the smallest features that you are able to identify, but still the image that you are currently using is huge. Okay, you want to make that image a bit smaller. Okay, so for example, right over here it is 1 2 3 4 5 6, 6 by 1 2 3 4 5 6 7 8, 6 by 8 image. Okay, this is a huge image. I want to make it a bit smaller. I want to convert it into a 4 by let's say 4 by 6 image. Okay, I want to make the image smaller, because the smaller the image, the easier it is to like use that image. Because the number of images, the number of the size of the image increases, number of mathematical computations that you have to do also increases, the complexity also increases. So to decrease the size of the image, but I want to decrease the size of the image while preserving the features. So the filters that you were able to apply, I want to preserve those features, I want to keep those features up with me, but still I want to decrease the size of the image. So what will be what will be I be using? I'll be using the max pool layers. So the max pool 2D layers are also the same thing. Okay, you are having a particular max pool layer. You have to specify the size of the max pool layer. So usually I will specify the size as 2, so it will take up size and stride. Okay, so size, if I'm specifying as 2, so you are getting a max pool of 2 by 2 size. Okay, you are getting a matrix of 2 by 2 size. Okay, now what does max pool does? It's the same as filter, but instead of like applying and function over the image, it will calculate the max in these 4 boxes, the maximum of these 4 boxes. So for example, right over here, let's try to change this a bit. Let's remove this. And let's put up the black once again. So this is our image right over here. When I'm applying a max pool, okay, so let's say that let's create the max pool as green. So this is the max pool layer right over here. Okay, it will calculate the maximum out of these 4 boxes. Now images are nothing else but numbers. Images are nothing else but numbers. So it will calculate the max of these 4 numbers and put it up in this particular box. Then I put up the stride. Okay, the stride as 2. I put up this stride as 2. So that stride defines by how many boxes, by how many pixels with this particular max pool layer move. Okay, by how many boxes or how many pixels will this particular box move. If I put up the stride as 2, now the box will move from right over here to the next, like it will move by 2 boxes. Okay, so it will move to here. Okay, so this will be the next max pool box. Okay, then again it will move by 2 boxes to here, and by each movement, by each of these strides, each stride you will calculate the maximum. So the for the red max, you will get the red max right over here. For the next green max, you will get the green max after that. Okay, that will be the maximum of the green boxes. Okay, the boxes are pixels. Yeah, Ankit, these are images. So the boxes are pixels. It will again move by 2. So it will come right over here. So it will give me the max of these. So as you're able to see, this, the entire length was 8 pixels. That has been converted using max pool into just 4 pixels. Okay, similarly it will move down as well, so it will calculate the maximum of these two boxes and put it up right over here. It will calculate the maximum of the next 4 boxes and put it at the maximum right over here. And as you're able to see, the width has also decreased from 6 pixels to 3 pixels. So your final image, that after applying max pool, you will be able to get 4 pixels by 3 pixels. You are having minimum pool, you are having maximum pool. There are many other pools that are there, but mostly you will be using max pool itself. Okay, because you want to, so for example, what basically you are doing is you are looking at these pixels, small area of pixels, taking up the maximum portion. So when you are basically converting this image into a smaller image, the image is getting blurred. That's it, because you're still keeping the major feature out of those 4 boxes. You're still keeping the major feature out of those 4 boxes. So the image is just getting blurred, but you are able to get a smaller image that you will be using. Now, this is just an example that you're using 6 pixel by 8 pixel image. In practicality, you will be having like 200 by 200 pixel image, or maybe like 1080 by 720 pixel image. So in that particular case, it becomes very difficult to be able to preserve the features moving further and to be able to do the calculations on that image itself. Hence, you are having the max pool layers to make the image smaller. Okay, are you guys able to understand this? Please let me know. Are you guys able to understand max pool layers and conv 2D layers? Are you able to understand these two layers? Please, please let me know, guys. Are you guys able to understand this? Please let me know. Guys, there are many of you live right now, so please let me know if you are able to understand this or not. Amazing, guys. You guys are so smart. Like, wow. Okay. So don't worry, tomorrow when we will be doing the project, I will try to make sure like tomorrow or day after tomorrow, we will be releasing the video. I'm not very sure. We'll be having the video either tomorrow or day after tomorrow. But the video will be made in such a way that these topics you will be able to understand these topics easily. You don't have to worry about it. Okay. Okay. So the next thing that I want you guys to understand is about loss. Okay, I want you guys to be able to understand about loss. Okay, so you are having a model. So this is your deep learning model. Okay, you feed in some inputs, you get an output y hat, okay, or y dash. Okay, now according to this input, the output that you should have got was y. Okay, according to this input, the output that you should have got was y. Okay, so what is the error, okay, of this particular model? This model has made some error right over here. Instead of giving you y, it gave you y hat. So what is that error? Okay, so to get that error, you are having various different ways to calculate it. You can have y minus y hat. Okay, the y that you wanted, the y that you got divided by y. Okay, you can get your like error from here. You can get your error from y minus y hat as well. Now the issue with this is that, for example, for some of these values, y hat is great. So maybe for some of the value, you wanted to get 10 as the output. Okay, you wanted to get 10 as the output. So you got 9 as the output. Now another time you wanted to get 10 as the output, you got 11 out as the output. So what is the net error that you got? The net error is 0, because if you are subtracting both of these, this is equals to 1, this is equals to -1. You want to add both of these losses to get you the final loss, and the final loss comes to 0. So according to your model, there is no loss. Your model was, there is no error, there is no problem, your model is working perfectly. You're getting the perfect answers. But as you're able to see, you are not. Your answer is not perfect. You wanted to get 10, you are getting 9 and 11 as your answer. To combat that, there are many different errors that are there. So you are having your mean squared error, the mean average error, the mean average squared error. So there are many error computations that you have. So for example, for mean squared error, so what they did was, instead of doing y minus y hat, they did y minus y hat the whole square. And then you take the summation of this divided by 2. So what is happening right over here is, or divided by n, depending upon how many numbers that you are having. So from I is equals to 0 to I is equals to n. Okay. For each of, so you are having your training data. These are basically rows of data. You are having your input data. You are having your output data right over here. Okay. You are having your output data right over here. So this is your output data. This is your input data. For each of this data, you will compute y minus y hat the whole square, y minus y hat the whole square, y minus y hat the whole square, and so on and so forth. Now these are 1, 2, 3, dot, 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 up till n. Okay. So the net error that you are having is the summation of all these like errors. Okay. So summation of I is equals to 1 to n yi minus yi hat the whole square divided by 2n. Okay, that is n is the number of errors that you are having, divided by 2n or n, depending upon how you want to calculate it. That is how you basically calculate your error, and you get to know how well your like how well your algorithm is actually performing. Okay, if it produces an error that is huge, then you will try to adjust the values of the convolutional neural networks and the other things as well. For example, maybe increase the number of filters, maybe increase the number of neurons, and so on and so forth, to get the error as small as possible. Now your error cannot be 0 until and unless you're doing something like this, y minus y hat. You cannot get a 0 error right over here, because there will always be some error. Okay, it's not always perfect, but you have to continuously go on with that. So are you able to understand what do you mean by error in machine learning? Please let me know. Are you guys able to understand what do you mean by error in machine learning? Please let me know, guys. Are you guys able to understand what do you mean by error in machine learning and deep learning or any other learning? Please let me know. Guys, are you able to understand error? Please let me know, guys. So error is nothing. You are basically calculating you're basically calculating the difference between what you wanted from the algorithm and what you actually got. That is the error. Okay, you aimed for like 90 marks, but you got 80. So what is the error? By 10% or 10 marks. Okay, so that is what you are calculating right over here. Okay, you're calculating the error that is happening for every single value that you are predicting, every input value that you are predicting. You are calculating the error for that particular value, and then you're combining all those errors to form the final error of your module, final error of your machine learning model. Are you guys able to understand this? This is pure mathematics. This is nothing else. This is not even machine learning or deep learning. This is basically 10 standard statistics. This is 10 standard statistics. This is a concept not from machine learning and deep learning. The concept from 9 and 10 standard statistics. Okay. Sir, understood by why such error exists. Sahil, because this is a student, this is trying to learn. Of course, in one go, he won't be able to provide you the right answers. So think about this model. Think about this model as nothing else but a huge machine with a lot of knobs and lot of dials that are there that you can adjust, lot of pulleys that are there that you can adjust. You will have to adjust these knobs and models every single time to get your product as close as possible to what you actually wanted. Okay, that is the main problem statement right over here. So you will keep on checking, you will keep on pushing into the production, keep on checking the material. Okay, this is not good, so I will adjust the number of neurons. Okay, I will adjust the number of layers, I will adjust the number of filters, I will adjust the activation function, I will adjust the input function itself. So all these different dials will have to tune, okay, so that you are able to reduce the error moving further. Are you guys able to understand this? Please let me know. Are you guys able to, Sahil, so were you able to understand this? Please let me know. Sahil, were you able to understand this? Please let me know, guys. Okay, great. The second thing is accuracy. I don't think so. I need to make you guys understand what accuracy is. Okay. So accuracy and errors are basically intertwined with each other. For example, you wanted to predict 9. Okay. Your model predicted 8. Okay. So, for example, what you wanted to predict y and what you have predicted y hat. Okay. So how many of these did y is equals to y hat? That is basically your accuracy, how accurate was your model was. Okay, what score, basically it is just saying that what score did your model get in your final test. That is called as accuracy. What score did your model get, your student get, when he gave the final exam? How many of the answers that your model gave were correct? Okay, so accuracy is measured in percent. So for example, if I'm asking 100 questions, so 89 of those questions were correctly answered by that model, so the accuracy would be 89%. Okay, I don't think so I need to explain you guys accuracy. Guys, you are able to understand what accuracy is, am I right? Do I need to explain accuracy to you guys? Please let me know. Do I need to explain accuracy to you guys? Please let me know, guys. Guys, do I need to explain accuracy to you guys? Please let me know. No need? Okay, great. So as you're able to see, this is a small example of an image. Okay, let me just make it a bit smaller as well. So as you're able to see from right over here, this is the image. Okay, this is I think so 5 or something like that, 5 or 3. I'm also not able to identify this handwriting. As you're able to see, this is the image. This is a 28 by 28 pixel image that you are able to see. Now images actually look something like this. Wherever there is white, the whites are zeros, as you're able to see. And wherever it is dark, okay, wherever it is black, it is having some values that ranges from 0 to 255. 255 basically means it's entirely dark, it's entirely pitch black. 0 means it's pitch white, and anything in between is a shade of black basically. Okay, so the same image, when you look at it in a matrix format, it's a 28 by 28 matrix that you are able to see, and it has numbers right over here. So are you able to understand this? Please let me know. So just look at this. This is a 28 by 28 pixel wide image that you are able to see. Are you guys able to understand this? Please let me know. You guys able to understand this? Please let me know, guys. This is the handwritten data set that we will be using to understand like in our project. As you're able to see, this is 504192131 4. So this is the data set that we are going to use. Okay, so it will be a very easy project. There won't be a lot of it. There is a lot of like code, as you're able to see, but I will make you guys understand it in a very easy manner. You don't have to worry about it. If I get time, I cannot guarantee you this, okay? But if I get time, I will try to make sure that I'm able to teach you guys how to deploy it to a project as well. But I'm not very sure whether I will get enough time to make that project. But even in the case, this entire notebook you will be able to understand in its entirety. I cannot guarantee for the web project itself, but if I get enough time, I will surely try to inculcate that as well. Will that be fine with you guys? Please let me know. Will that be fine with you guys? Please let me know. For the next boot camp, that is the backend web development boot camp that is going to start from the 16th. We have already got 8,800 people who have registered for that boot camp, and we are still almost how many days? This is 8th. So we are like almost 8 days away from the boot camp. So I guess the next boot camp is going to be very huge, according to me. Okay. Okay, so for the project, again, guys, I'm letting you guys know from right now, we are going to use TensorFlow 2.0. Okay, we are going to use the latest version of TensorFlow that is currently there in the market. Okay, TensorFlow 1.0 also exists. Okay, you can learn that, but the latest version right now that is out of beta and now being used by everyone is TensorFlow 2.0. So when if you guys means 2.x basically, like I'm also not very sure whether TensorFlow, so it will be TensorFlow 2.8.2 as you're able to see. So we'll be using Python 3.7.13 as well as 2.8.0. Okay, so you guys can continue from right over here as well. If you want to register for the upcoming boot camp that is there from 16, you can just go to devtown.in. That is our website, devtown.in. Just go to events section. Okay, you will be able to find the next bootcamp, learn server authentication using MongoDB and Node.js. That will be our next bootcamp right over there. You can definitely take part. It is a backend web development bootcamp. So we'll have a lot of fun in that as well. Okay. Okay. Thank you so much, guys. Let me just show you the attendance link for today. Give me some water. There are just so many Google Forms right now that I have to maintain that sometimes even I also forget about the boot camps themselves. So how many of you are from Bangalore? Can you guys let me know? Any of you are from Bangalore or you are currently living in Bangalore or you have your college in Bangalore? Please let me know. Harsh, we didn't had any notes today. There was no notes. We had everything in a written format. How many of you are from Bangalore or like your college is in Bangalore or something like that? Can you guys let me know? Uh, Abhay, it becomes very difficult. Sometimes I just contemplate whether should I take the class today or not. But yeah, it's my responsibility and I try to take it very seriously. Okay, so Abhishek is from Bangalore. That's great, Abhishek. So let me just show you the link right now. Bhubaneswar KIIT. We are planning to come to Bhubaneswar, I think so, during your college fest. It happens during December, I guess. So we are planning to come right over there. Okay, so this is your attendance link, and I will show you the QR code as well. This is the QR code, guys. From the next bootcamp, I think so. We'll have like 3,000, 4,000 students live with us. So we will have an amazing time from the next boot camp. Okay. So I hope to see you guys right over there as well. And we'll try to make sure that it's an amazing learning experience for you guys. Okay. In the next boot camp, we are inculcating some new features as well for the boot camps themselves. Let's see how that goes on as well. Okay. Okay, guys. So thank you so much for being in today's class. We'll meet the next time. Thank you so much, guys. Thank you. Means tomorrow, of course, we are going to meet. So let's wait for tomorrow. Okay, thank you so much, guys. Thank you.